This video shows how a telco engineer can use low-code tools like Node-RED and the Wilab API ecosystem to create automated workflows that continuously monitor service performance, analyze issues with an AI model trained on telco data, suggest workarounds, and trigger corrective actions via webhooks. We'll now guide you step by step through the process. For example, using these tools in a real-world scenario in Fairview, North Carolina. We found that the Service Experience Index is 1.9 on a scale from 1 to 5, with 1 being very poor and 5 representing optimal service experience. There are 3 cells with poor service experience, affecting 125 users. We also see that the services impacting the overall service experience the most are video on demand and cloud background traffic. These are apps like YouTube, Google Photos, and iCloud. With all this information, the suggested action is to block video on demand and cloud backup traffic momentarily to prioritize essential communications on the network. Now let's drill down how we managed to gather all that information. The workflow starts in those nodes that query the Service Experience API to get the service experience score for different regions. Next, in this node, we check if the service experience is below 2, and we trigger a drill down to get more information. In this drill down, we first query the cell API to identify how many subscribers are affected. In these nodes, the system gathers the necessary information to automatically write the prompt for the LLM. First, in this node, we gather traffic samples from affected cells. Second, in these nodes, we identify heavy users through the Heavy Users API. Now the workflow sends a dynamically generated prompt to our telco-specific LLM. The LLM analyzes traffic patterns and calculates an impact score for each service category. We used Azure AI Studio for this use case and selected the Llama 3.1 model. We have separated the per-category impact score calculation into 3 task-specific prompt flow nodes. The first node categorizes the URLs we gathered from the EDRs using keywords that the model finds in the URLs. Then the second node summarizes those categories, leaving the URLs behind and adding their uplink byte sum, downlink byte sum, and their hits to its parent category. The third node calculates the impact score based on specific predefined patterns and guidelines contained in the prompt. The model then returns an object that shows the top categories impacting the service on the selected network slice. Here we see that video on demand and cloud background traffic are generating the most impact. Returning to Node-RED, we can see that the LLM output flows back into here, where the system determines if any service category has a significant impact on the user plane congestion and if the communications service category is being affected by that. Since video on demand and cloud background traffic are non-essential, corrective action can be triggered using a webhook, and it can be executed automatically using an automation framework like Nephio.